Last time we were looking at the role of construction process in helping to make architecture reach its aspirations. And in particular, we were looking at a case study of Amiens Cathedral, where we could see that without all of those careful solving of construction problems, we could never have had a building that would reach the aspirations they had in those medieval times. Today, we're going to be looking at the way that construction process innovation can really be a spur for incredible leaps in architectural innovation, either in a landmark building that could never be built without that kind of innovation, or even a whole era of architectural work that is spurred by inventions and innovation in the construction process. The first building I want us to look at today in terms of this innovation in building process is the great cathedral, the Duomo in Florence. The official name of it is Santa Maria delle Fiore, and it was built between 1296 and 1462. And it really had two primary architects. There would have been others as well. It was a huge, long process. But two architects, one is Arnolfo da Cambio for the early part of the building, and then Filippo Brunelleschi for the latter part. And we're really going to be focusing primarily on Filippo Brunelleschi. This is the landmark building in Florence. It's what everybody thinks of when you think of the skyline of Florence. And it really was incredibly important in really developing the Renaissance. It was the church that kind of spawned hundreds of Renaissance churches that were very similar to it. It was an enormous, influential building, not just in Italy, but really all over the world in years to come. But it really started with, I'm going to make the argument, a fundamental advance in building process. So let's roll back and look for a minute at what the situation was there in Florence. Florence in the 13th century was not at its best. This is only 8 years after Amiens. And this is like a completely different building than you'd see a Gothic cathedral. But it's just 8 years. It was started 8 years after Amiens was finished. And in that era, France had really been in the ascendancy in terms of architectural quality. They had kind of invented the Gothic cathedral. It had moved to Germany. Germany was making great advances in Gothic cathedrals. But someplace like Italy was not really the center of any kind of architectural innovation in the design of the Gothic cathedral. There was something referred to as Italian Gothic. Often they would even import designers and craftsmen from France or from Germany because they knew those processes better. But it wasn't really, Italian Gothic was not a hugely innovative era of Italian architecture. But they were planning a cathedral for Florence, and they planned it to be in the Italian Gothic style, and that would have really been the work of Arnolfo da Cambio there. And they started building it in the 13th century, and we're seeing those dark black walls there are the walls that were built at the beginning in the Italian Gothic style. Now, one reason why Italy had not been in great ascendancy then was because there was a lot of internecine fighting. Italy was kind of city-states at that point. Even in Florence, there were two big families, the Guelphs and the Ghibellines. They were fighting each other. They had alliances with all these other families, and everybody was kind of not pulling together. And even in this period, they're building this. It's a period when the culture is not advancing so much. Then in 1350, they had what was called the Black Plague, which was horrible. It was like a pandemic that killed 40% of the population of Florence. So horrible, horrible event. It took years for them to recover from that. It wasn't until 1367 that they kind of got back on their feet. And at that point they decided, you know, maybe we don't want to do Italian Gothic. Maybe we don't want to do a standard nave, side aisles. At the end would have been a crossing in the normal Gothic style. Maybe we have bigger ambitions than that. And they were beginning to get a little bit of handle on their internecine fighting. And maybe the pandemic, other things had made them cooperate with each other a bit more. So they began to have higher aspirations. Maybe we could do something that wasn't just like the French are doing, a sort of second-hand version of that, or what the Germans are doing. Maybe we could do something that was really more about our culture. And at that point, they could travel down to Rome and they could see the Pantheon. They could see this amazing dome down there. Now, at that point, they didn't know how they built the Pantheon. We kind of still don't know how they built the Pantheon or Hagia Sophia. We know what they did, but we don't necessarily know how they accomplished it. So they go down there and they're seeing the Pantheon and they're thinking, wow, this was our culture. We did this. Why couldn't we do this again? And so they had the idea of, instead of making a Gothic termination of the building, instead of finishing it out like a Gothic cathedral would have been here, instead, maybe they would make a dome, a big dome at the end of this building as you went down the nave. And they got the idea far enough along that they built a little model right there. Well, it wasn't a little model, it was a huge model. In this era, they were totally into making these big models. So they made a model of what the cathedral would look like if it had a dome at the end. Now, mind you, at that point, it stops right here. And they have the idea of a dome at the end. So this is maybe latter part of the 14th century. By 1400, they feel pretty committed to, we want to do a dome at the end of this. So they begin to, that's the dome they imagined there. That's what the model looked like. And that model was actually big enough. They put it inside the half-completed church. And it was big enough that people could get inside it and look up and see what it would be like to be in a dome as the termination of the building. So people got super excited about it, and there were drawings made. The idea was there. It was meant to be, at that point, a lower dome than the dome that was eventually built, but that was the idea originally. So they began to build some of these semi-domes, and we saw in Hagia Sophia how those were important for carrying those loads down. And they're preparing to build that big dome, but they don't know how to do that. So they have some buttresses and they have some semi-domes, and they're beginning to kind of work their way up the building. But all of this is being done without any assurance of how they're going to actually build that dome. So it wasn't until 1418 that they had a competition. And they said, okay, we're going to invite some architects to come in and give their best shot at what would be the right construction process to build this dome. So there were a number of people who entered that. There was one, and of course, at the time, they could not have built a steel armature to then build the dome on. They couldn't have built all the scaffolding that would have been necessary to build the dome up at the top. So it was a very, very big challenge. And they, like I said, they could go down to Rome and see the Pantheon, and some of these people who entered the competition did that, but they had to figure out how to make it happen. Now, there was one entry in that competition who, personally, I think the guy should have won, but he didn't win, but it was a very interesting idea. His idea was to take dirt from the countryside and to build a mountain where you wanted the dome to be in the shape of the dome, just build the dirt up like that, and then use that as the formwork to build the stone shell that would become the dome of the cathedral. And then, of course, people ask, well, wait, how do you get all the dirt out from inside the cathedral? And he said, oh, that's no problem. We'll plant coins in that dirt periodically, and then we'll announce to the people of Florence that there are coins inside that dirt, and they're so greedy, they'll figure out a way to get in there and get the coins and pull the dirt out of the building. So he didn't quite win, but it was an interesting idea. But you can see the challenge of, we know the dome will work when it's all built, but how do we actually build it? Now, the guy who actually did come up with the ideas of how to do that was a guy named Filippo Brunelleschi. And Brunelleschi's father had been working on the dome, on the cathedral, for quite a long time. He was a well-known architect in Florence at the time. He had won other competitions for much smaller kinds of projects. But he was a very driven, very skillful, already very well-respected architect in Florence. And he, at that point, the cathedral would have been built about up to there. And he comes up with a solution for how to build the dome. And this is fundamentally, in some ways, the beginning of the Renaissance. Often he is credited as one of the fathers of the Renaissance because he figured out how to do this. And that was a fundamental change. You can see the enormous difference between a Gothic cathedral, which was the previous era, and this is foretelling a whole era of Renaissance churches that were completely different with that kind of dome construction. Now, there were 4 different things that Brunelleschi came up with that were fundamental about his dome. One was he wanted to put a timbre or a drum to lift the dome. A second was he wanted to build the dome first with ribs and then infill. A third thing is he decided to build 2 layers of the dome and link them together in order to sort of build it in stages. And the fourth was this notion of using reinforcing with chains around the dome. And that the combination of those different things enabled them to construct the dome. So let's look at those individually. So he had this notion of raising the whole dome, not flattening it out with all these semi-domes and sort of just making a mound there, but standing tall and proud on that timbre or drum like that. And that also was resolving all those loads and allowing him to really just take the shape of this dome and take those forces right down into the rest of the building. So one of the fundamental things here, the second thing, is this making of ribs. So there are 8 major ribs that he articulated on the outside here. But between those major ribs, between each of them, there are 2 minor ribs. So that makes a total of 24 ribs that would have been built all the way around. And by building the ribs first, you could partially build the dome without having all the weight of the dome, and then do infill slowly back into that and complete the dome that way. So it was sort of a divide and conquer kind of approach there. This little drawing is interesting because Brunelleschi not only had the kind of macro idea of how to do this, but he invented all the hoists and the cranes and all the mechanisms for how the material would get up there and how heavy it would be and how many people it would take to operate it. And he was very much involved in all of the details of the construction process, as well as these sort of 4 big ideas. Then, as I said, another big idea was to build 2 layers of the dome with a space in between. That meant that you could build half the load-bearing capacity and the other half the load-bearing capacity and then tie it together rather than having to build that all at once with a greater weight that would be involved in it. It also gave a passageway so that the workers could carry materials and themselves to get up to areas where they were constructing on a given day. So that became a kind of armature for getting up into the construction of the dome. And to this day, you can take that passageway and go up to the cupola at the top of the dome, but it was originally built as a construction device. And there you see that passageway between the two layers of dome there. And then the fourth idea was this notion of the chains that you see in these sort of little dig out places here where they place the chains and grout them in. And that acted as a kind of belt to take those thrusting loads out and keep it attached in. And there were various points around here where they put a kind of girdle that would pull the dome in together. So it's really that combination of the timbre or drum, building it first, and then the ribs, and then the two layers of dome with the space in between, and then these reinforcing rings that went around. And by doing all of that, they could slowly, step by step, construct the dome. And as I said, Brunelleschi was very involved in all of the scaffolding, the design of the scaffolding, the supports of the scaffolding. All of that was essential in figuring out how do we actually get this thing built. Now, in the end, there is this magnificent space underneath the dome, and at the time, instead of coming down the nave in a Gothic cathedral and basically seeing a cross aisle that looked the same, instead you come to the end of the nave and there's this amazing big open space with light pouring down from this tambour. And then they had fresco painting on the ceiling of it. It was a blowaway. It was a magnificent new innovation in how you build. And it would never have been possible without Brunelleschi's incredible, astute knowledge of how you build and of how that construction process can accomplish the goals that they had at the time. A second project I want us to look at is a much more contemporary project, a 20th century project. And just to show that this kind of construction innovation is still going on, and there still are challenges we give ourselves architecturally that require a fundamental innovation in building process in order for them to be realized. This is the Sydney Opera House. Has a very interesting story that goes with it. It was won in a competition. The city of Sydney decided we want to build this magnificent opera house. We talked about it in an earlier lecture as a kind of representation of the nation of Australia, the city of Sydney, the aspirations of this rather remote culture down in the southern hemisphere. And so the opera house was going to be a big move for them. They have this big competition. Actually, the chair of that competition jury was Eero Saarinen, whose work we looked at in previous talks. He was a very, very famous architect at the time in the United States. They gathered other architects from all over the world, and they brought them to Sydney in order to jury the competition. There were hundreds of entries to the competition. It turned out that Eero Saarinen's plane was delayed. His flight was canceled. And that was back in the days when you didn't have 4 or 5 flights a day to Sydney from New York. Instead, he had to wait several days in order to get a flight to go to Sydney. So the rest of the jurors have convened in Sydney, and they're waiting for Eero to come. So they decide that they'll go through these hundreds of entries, and they'll call out maybe the 30 or 40 best ones and leave them upstairs and send the rest to the basement. And that way, when Eero comes, he can just look at the best ones, and they'll make the decision from that. So Saarinen shows up a few days late, and he looks at the ones they've called out and premiated, and he says, whoa, there's nothing in here that's good enough. Nothing in here that's spectacular enough to live up to these high expectations the Australians have here. So he goes back down to where they'd taken the rejects, and he starts rifling through them. And as he rifles through them, he comes upon this just very sketchy set of drawings for one submission. It actually did not meet the submission requirements. It did not have a budget and cost estimate. There were a number of things that were just missing. But Saarinen looked at that and he said, wow, that's freaking amazing. It's so sculptural, it's so perfect in that harbor. It's like sails of boats. It refers to the harbor bridge. It's, you know, what a spectacular thing that would be. And he could see, even from those meager sketches, how amazing this building would be. So he goes back up to meet with the other jurors, brings this one up there and says, man, this is it. This is what we need to be making the winner. And there was a lot of discussion back and forth, but this guy was very convincing. And in the end, they decided to make this submission the winner. It was submitted by a young architect in Denmark named Jorn Utzon. Nobody ever heard of him. When they found out who that was, they contacted him in Denmark. They brought him to Australia. Turns out he was a tall, good-looking, rather charismatic guy. So they thought, okay, well, we can make this work. And they decided to go public with it and say, okay, this is the opera house we're building, this funny little sketch here. Now, when it became public, there were a lot of skepticism about it. And unfortunately, I mean, Jorn Utzon did this as just a kind of lark, a competition entry. And he did not sort of think through exactly how would it be built. So he didn't know what the building process would be to construct the Sydney Opera House. He thought that he would make it out of thin shell concrete, which was a innovative building process that people were interested in at the time. Eero Saarinen was very interested in it at the time, and he had done a building out of thin shell concrete. But the thin shell concrete had to be a perfect structural shape, like a sphere. And these were very irregular shapes. And as they hired an engineer over Arup to come in and analyze the building, it turned out it really didn't work to do it as a thin shell concrete structure. They were just beginning to be able to do computer analysis of buildings at this point. Over Arup was the leader in this. They did all kinds of analysis of the structure of the building, but also of how they might build the building. And they looked into various, could they precast it? Could they build it out of steel? Could they build it out of concrete? What would the process be for any of that? Now, in the meantime, the building has to start construction because politically there's public money in this, and they can't just be announcing they're going to do this and then sit around for a year trying to figure it out. So there's political pressure to go ahead and start the foundation. So they do that. They start, it's in the harbor. There's very difficult foundation condition. It's on Bennelong Point, which is a kind of peninsula into the harbor. And so they began the construction of it. But they still don't actually know how they're going to build those shells. So one morning, Utzon is having grapefruit for breakfast. And he realizes when he looks at that grapefruit, which is a sphere, and he cuts various shapes out of it, he can make forms that look remarkably like his sails. Now, not exactly like his sails. These are much steeper. His sketch was much lower and more pointy shaped. But he looked the advantage of cutting it all out of a sphere, out of the same radius, was that it behaved better structurally, and it would allow them to precast much more economically, which would mean that they'd be able to have more repetitive pieces, and it would be somewhat more economical to do. And then they could precast them below and hoist them up. And of course, by now there are cranes and the ability to actually get all that stuff up as precast concrete. So that then began to give a mechanism for how you would construct it. And that got tested out, and they built it out there on Bennelong Point. Turned out that the original foundations they put in when they didn't know how to build the sails weren't going to carry the right loads for that reconfigured sail, so they had to go back and do some additional work on the foundation. All that's super inefficient, but it got the job done. And then at every point along the construction process, Whitson is actually very good at figuring out how do we make these beautiful tile scales on the building, and how are they fabricated, and where do they come from, and how do we make that work? And then that's very important in making it kind of shimmer out there on the water and sit as it does as a great piece of whitish sculpture on the skyline of Sydney. Now, Whitson was one of those guys who just pushed the envelope at every point. Every single material, every single assembly, he was ready to do innovation. And in this particular area, he was interested in making that shape all out of glass, 100% glass. No steel here. He wanted it all to be glass. And he knew that you can use glass structurally. It's a challenge. But he found some people in France who he thought could make this structural glass. Some of it would have been 2 feet thick, 2-foot thick pieces of glass that would have jutted out and made that shape. And then you'd be able to get this panoramic view of the harbor and the bridge and the city with no obstruction of structure, just pure glass. And he thought that would be magnificent, and he's on the path to figure out how do we make that work? How do we make the building process produce that? Well, at a certain point, this was taking longer than it should have taken. The building took 17 years to build. That, for a 20th century building, that's a phenomenally long building process. People are getting incredibly impatient. When are we going to get our new opera house? And so, sad to say, at a certain point, they fired Jorn Utzon and said, dude, you just pushed the envelope too much. And the building was actually completed by other architects and done rather sensitively. Some of those architects had been working with Utzon, kind of knew what he had in mind. But Utzon himself went back to Denmark and actually did not see the building finished until 30 years later, when he was hired to do some renovations to the building. Now, the general character of the building and the skin, all of that is pure Utzon. But when you go to some of the interiors, for instance, all of that steel, that was all produced by the other architects. It's a good solution. It's not as perfect as Utzon's solution, but it allows a good bit of visibility out to the harbor. There are other places where Utzon's innovation was really executed pretty thoroughly by the architects that followed him. All of the interior of the halls had not been designed when he left the project, so those had to be designed by the new architects. And all of these interior finishes are really probably not what Utzon would have done, but are certainly done in a very skilled way. But the point is that this was one of those projects that just start to finish, every point along it, Jorn Utzon's notion was we have an aspiration and then we figure it out. How do we figure out a building process that'll get us there? And you would not have this incredible 20th century landmark building if it were not for that attitude. Now, the original budget for the Sydney Opera House was $3 million. The actual expenditure for the building was $108 million, more than 30 times the original budget. It was very controversial. In the end, the Australians voted to have a lottery, and the income from that lottery would pay for the Sydney Opera House, so it didn't have to come out of regular taxes. And the Australians loved to gamble, so the lottery was very popular. The money came in and it paid for the Sydney Opera House. But to this day, even $108 million, money well spent for the kind of visibility and the kind of ambition and thrill that that building produced, and a real strong message about what is Australia in the 20th century. So again, this is very innovative construction process, in this case at some significant expense and time required to do that. Okay, see you next time.